This
Okay,
conference will now be recorded.
okay. So this is a fundamental test process that we are looking into. First is test planning and test control. Okay. So the first thing we do is test planning. So what exactly is a test planning is? So dev team will have a separate plan for development, and testing team will have a separate plan for testing this thing. So what we do in test planning is we establish the scope. Okay. So we have the requirement document and all with us. So on the same document, dev team will also start working, and testing team will also work. So what we do is we identify the what exactly we have to develop, what exactly our developer team will develop. So what exactly we are going to test it. So that is how we start establishing a scope of this test planning. And we are in test planning, we also do we approach the resources and we find out how many resources do we need for this particular testing. Okay, suppose we have got a huge chunk of data and we need we estimate that we need at least 4 to 5 QA resources for this particular team. Okay, then the team lead QA lead will go and search for the particular resources, and then he'll get the resources and he'll interview them, and then he'll get into the project and he'll tell, okay, this is what we have the requirement and we have to start testing. So we approach the resources and we get the resources in the test planning phase. And the other one is also we scheduled specific task in test planning. So something like we specify the deadlines. So this is this much time we take for analysis of this particular thing, and this much time we take for test design, and for implementation execution we have this much time. And the last one also, we also identify what to be tested, what not to be tested. So whatever development team will develop, we consider all those points, but there might be few scenarios. Suppose in automation testing, all the manual test cases you write cannot be automated. There might be some challenges that you might face, or there might be some scenarios where automation is not needed. So in that cases, when you are doing a test planning and you have an automation in your project, so what exactly you do is you identify what needs to be tested as part of manual testing, what needs to be tested as part of automation testing, and what need not be done as a part of automation testing. These all identification things we do in test planning. So, and on the lower level, we have a separate chapter for this. We can go through everything one by one. It is on a high level just to understand what exactly is test planning and what exactly is test control. So now coming to the test control. In the test control, what we do is we plan whatever we plan in the test planning stage. Generally doesn't go according to it. Suppose we give a deadlines and we based on some other interference or some other so suppose dev team has supposed to be given you a document to understand the requirements, but it was delayed by 1 week. So but in test planning you have already mentioned the date, like we'll start it from today and it is being postponed to next week. So those are all things you control in the test control phase. Okay, so test control, we develop and carry out corrective actions to get the test project back in correct. So suppose this is delayed by 1 week, right? Whatever document you need to get from development team is being delayed. So what you do is we generally adjust it in the next phase called analysis and design. So suppose in analysis and design, you have given like 2 weeks, there you shortcut your days, like 4 days or 3 days, and then you try to adjust it. So these are things you do in test control things. Test control phase. So these planning and control mostly will be done by QA lead only. Will not be interfered mostly in this. If at all we get a chance, it is very good for us to get into this stage also. And so coming to the next section, that is test analysis and design. Here is where so we have already identified what to test, right? So we start analyzing the scenario. So suppose I'll tell you one simple scenario. So suppose we have a scenario where we are building a new UI for that particular e-commerce website. Okay. So they want two fields like username and password, and the third one is a login button. Okay. So what you do is you have already decided what you are doing in a planning and control phase, and now you have to analyze. So what you do is you analyze this particular page. Okay. So you analyze this document in requirement stage. So there will be few scenarios or few requirements where client will ask us the username should only have all the alphabets. It should not contain any one at the rate kind of things. And password should be like capital P and everything should be small and there should be a star. So these kind of things will be in the requirement document, not in detail, but on the high level you can find out a few requirements from the client. So what you do is you identify those scenarios. Okay, high level scenarios you identify, and then get a view. Okay, so now this is the requirement page. So they are building a UI for e-commerce website, and now ideally for a login page, what else we have to do? It is a username and a password and a login button. So these are the things that we need to have on the UI page. So we start analyzing things and we start the design. What is design? uh, what in design stage, what we do is how we will test during test analysis. And in general, test objectives we transform test. So test conditions will be written in the analysis stage, and we write the test cases in the design stage. Okay. So these are all when you are in a project, you don't ideally find, okay, now we are in test analysis stage, or now we are in test design phase. It all goes in a flow. You just have to analyze. Okay, when you're start writing the test cases, then automatically you should be knowing that, okay, this is in design stage. Okay, then you will be like, okay, in design stage it might take this much time. So you can ask, and you can always go to the QA team lead and you can ask, okay, what estimation we have given to the design stage, and what is the expectation from the client, and all these things will be a productive talk with your team lead. And he will also be knowing, okay, he knows something about testing and he's interested. So this type of conversation is always good. So this analysis and design stage, what we do is we analyze what exactly we have to do on that particular page, and we start writing the test cases. So what kind of test cases, right? A positive testing or a negative testing we can do. So these also I'll explain you. These on the high level I'm explaining you in the first chapter. So what is positive testing? Entering a more normal username and normal password and clicking on login, it is a positive test case. And coming to the negative testing, what is negative testing? You'll not enter the username properly and you'll not enter the password and click on login, then it is a negative test case. Whatever is not positive is obviously a negative test case. So that is how you start doing analysis and design on the particular requirements document you have been given. Okay. And then coming to implementation and execution. What is test implementation? So you have already test cases, test scenarios in place and test cases in place. And now you have already designed everything and you have to start implementing it. So for implementing, see, suppose for this scenario, for this example, there is a username and password field, right? So for this username and password, you have to create username and password before you log into this. There should be a sign up page. Okay. So you start creating a test data for your testing. So you have to go to next phase is execution phase. So for execution, whatever is needed, you start collecting all the data before going to the execution phase. So that is called implementation. You set up the environment, you prioritize the test cases. So suppose there are two requirements and client come up and tells, okay, second requirement is first you have to do, and first requirement you can do it later. So that is kind of input we get from the client in after. So then what you have to do, you have to prioritize things, right? You have to first complete the test cases of the second requirement and then come back to the first requirement. So that is how you all plan and you have get everything in place when you are going to the execution phase. Okay. So then what is test execution? And also I want to add one more point here. In test implementation phase, when you're an automation tester, what you do is you identify, see, I have told you, right? In automation, what exactly happens is if you write 10 test cases for manual testing, all the 10 test cases will not be automated. Suppose you say there is a five test cases scope that you can automate. So you pick those 5 test cases in implementation phase and you start writing the test scripts, and then you write all the test scripts from the scratch and you get ready everything. Okay. And in execution, if you are doing a manual execution, then manually you whatever 10 test cases you have identified for manual test execution, you start writing them, you start building the you start executing those test cases, and then after in automation, whatever the test scripts that are ready for you for execution, you just run them and just see the results. Okay. So that is what we do in test implementation and test execution phase. And here we can also check the actual results in implementation and execution phase. Execution phase, what you do is we see the actual results of the test cases and what is the outcome of the test case, and we also compare the actual result with the expected result. So suppose here in the positive testing, what happens is you enter a proper username and you enter a proper password and click on login. What happens is it should ideally go into the login page. Okay. So that is what is expected. Okay. What is actual result? Actual result, you only get it when you actually perform the particular action and then you see it with your eyes. So actual result also you can note, I'll explain you in the test case writing when you do it, but actual result also you write it prior in the analysis phase, execute implementation phase. Okay. And then you verify this outcome, right? So you write a username and password and click on login button. What happens is expected result is login should be successful, and actual result also login is successful. So that is how you execute a manual test case. So that is what is called implementation and execution phase. And coming to the next one is evaluating exit criteria and reporting. Okay. So what is exit criteria? Exit criteria is like not all the time we keep on testing the same product again and again. There should be some point that we should have a checkpoint to complete the testing process. See, suppose first of all we have a requirement. Okay. The requirement is username and password, positive test case, negative we don't no username, no password, login, it should not go. Okay. Then they develop more and more. So this part of testing is done. We told the client, so it is working as expected. Everything is done. Testing is done. So they again come back, say that this username should be so and so alphanumeric and password also should be alphanumeric, and then login. Again, they start developing, they start testing. Okay. So this cycle goes on, but we should have exit criteria. We should have a particular point where we can stop this testing. Okay. So first one requirement is done, then test closure is done, and then again they come with the requirement to only then we start the testing. It's not like the requirement is done and again they come back and they ask us to test it. Again, we do it in the requirement one. So no, this is not possible. You have to tell the client saying that no, we cannot do it because this is not as per requirement. If you can come back with requirement 2, we can start testing. So this kind of exit criteria should be there, and there should be some reporting tool. Where here itself in the reporting tool we have ALM, Jira, or something like Azure DevOps. Everything we use in this particular criteria. So this is where we do an exit criteria, and this exit criteria will already mentioned in the test planning phase only. We while planning this thing, we also include what is exit condition, what is exit criteria, and what are the tools we are using in exit reporting tool. Suppose there will be few projects which would be liking to go for cloud, so they use for Azure DevOps. No, someone wants the old traditional method of ALM, someone wants Jira. So it all depends upon the client requirement and the budget constraints and all. So those all things will be already included in planning stage. We just use them in the reporting stage. And test closure activities, so whatever test activities we have completed, we create a document and we can say, okay, so this is what the requirement is, and these many test cases we have created, and these are the results that we have given, and this much is a pass percentage, and all the metrics, whatever we have done in all these phases, we do a detailed report and give it to the test closure activities. So, and this one also is mostly handled by QLE. Mostly our if we are going into testing newly, and we will be mostly involved in these two majorly into these two phases, and they will, if you go into the project, they will not tell you saying that, okay, this is test analysis, this is test design stage, and here we are into implementation. You yourself should analyze, okay, we are here, we are writing test cases, so it is into implementation. Okay, we are still writing the scenarios, so we are into design phase. We are executing the test cases, we are into execution. So this should be in your mind, so that it will be easy for you to progress in a next future activities. Okay, so this is what is a fundamental test process we have. And coming to the next this thing, it is a 7 testing principles. Okay, so basically 7 testing principles. The first testing principle is okay, I'll explain you here. Okay, first we'll have what are all the 7 testing principles. Okay, the first testing principle is testing shows the presence of defects. So you have to understand one thing is testing shows the presence of defects. Okay, and the second one principle is exhaustive testing is impossible. The principle 3 is early testing. Principle 4 is defect clustering. Principle 5 is pesticide paradox. And sixth principle is testing is context dependent. And principle 7 is absence of error fallacy. So these are the basic testing principles. So everything, if we are developing any product or if we are doing anything, there will be some principles that we have to follow. So similarly for testing also, we have these 7 testing principles that we follow, so that it is a standard thing every tester should know. As a tester, we should know all these 7 testing principles, and also it should be remembered for ISTQB preparation. So these 7, out of these 7 testing principles, there will be at least 2 questions that we can expect in when we are attempting for ISTQB. Okay, now we'll go through each and every principle. Okay. So testing will never prove that there is no defect. Always has scope of improvement. Okay. So even though if you tell the testing is completed, there will be some or the other defect or other thing that it needs to be improved. Okay. So that is where we get different requirements, and we get different ideas, and where again we start everything, different projects also. So first thing what we have to understand is testing will never prove that is no defect. So we have completed our testing. That means that is not sure that there is no defect. There might be some defect, or there might be some improvement that needs to be done for the particular project. Okay. So that is first principle. And the second principle is, it says you can never ever test a product completely. So you can, second principle is exhaustive testing is impossible. So that is what you keep on, they keep on giving the
Hello,
requirements, you keep on. Hello.
madam. Can you please make screen bit bigger?
Yeah, okay, is it okay? Hello.
Yeah, it's fine.
Yeah, sure. Okay. So exhaustive testing is like they keep on giving a requirements and you keep on testing it. This is a process, continuous process, and this cannot happen continuously, and you cannot give the you cannot say that testing is completed. Okay, so as an ideal tester, we should never say that testing is finished. We just say that testing is stopped. Okay, if in a project they ask you what about the requirement, that particular requirement testing is completed, then you say, okay, you should not never say, okay, that requirement testing is finished. You cannot say, because there might be some improvement, there might be something that you have missed, there might be something. Okay, so we have to say, okay, we have stopped the testing for that requirement, and now you can go through the next this thing, test closure activities. Okay, and the third principle is static testing and early testing, QA testing, everything are same. I did not explain you about static testing, right? We'll do it. So what is early testing? So early testing is something like building up building a product and then testing it immediately. So I will tell you one example here. What happens is you start yesterday in one example we have mentioned it, right? While preparing a bag, you get all the requirements and you start preparing the bag, and in finally when you give it to the testing team, there might be more defects, right? So what we can do is once and all, you have refurbished the fabric that you have got, and you have cleaned it everything, and you have recycled it, and now you give the thing to the product to the tester. They say, okay, the fabric is good, now you can go ahead to start stitching the bag. Okay, now you stitch a bag and then you give it back for testing. What happens is, okay, now the fabric is fine. And the bag is also as per the requirements. We can go ahead and giving the product to the customer. So testing uh, at the early stages will help us to minimize the development effort and also minimize the defects that we are facing. Okay, so early testing is always good. It is always good for if at all we are building a product or anything. It might be building up a TV or a mobile, or you are stitching a something, even everything that is coming out as a final product, early testing is always good. And the fourth principle is defect clustering. So I'll tell you with an example. Defect clustering. Cluster is like where you get all things in a place, right? So that is called a cluster. Okay. So defect clustering is like, so now you have tested this and it is going to the login page, and then there in the login page you have a few things that you have to perform. Okay, so you have tested this and you have got a go, and then you go to next you when you click on this login button, it is not navigating to the next phase. So what happens is, you tell to the developer, okay boss, this is not working, this is not going to the next page, and then he come back, he fix it, and again you log in, and then in the next page you see two, three, four defects at a time. Okay, something like it has to navigate. There should be a drop down. There is no drop down, and the text box is not proper. Text box is not proper. It is not able to enter the values. And then there should be a button here beside that particular text box. There is no button. So you see most of the defects in one page. Okay, right? So that is where a defect clustering is. So where you find the most of the defects is called defect clustering. So in any web or mobile application, there might be an area where faults or defects are found. Okay, so when you navigate to the next page, that the page you have identified, okay, this is a page where we have defect clustering. Okay, so this is where we find more defects, and we have to tell the developer team. Okay, that is how we identify defect clustering. And the fifth principle is pesticide paradox. So pesticide paradox is testing the same scenario with positive scenario again and again will not help you. So here in this login page, you enter the username, you enter the password, and you log in. So this is the only thing you keep on testing. That is not helpful. You have to do all the scenarios where it might throw you an error. So that error you have to find out. You should be capable enough to find out that error. basically you should be having an eye of negative eye, testing all these things. So you should try to find out the issue in a page. So whenever you have given something for testing, you just start seeing all the negative things which you generally should not see in your life. But when you come to this testing, that is what main tester role is. You should start saying, okay, when I don't do this, what happened? When I don't do this, you can do whatever you want. You just have to deliver a product, good product. So what all the things you do and you give defects, that is how you can test a product very good. So that is called pesticide paradox. Pesticide paradox is not good, so you should not follow this. It's like testing the same scenario with positive scenario again and again gives nothing. You have to test with as many as negative scenarios. Whenever you give so many negative things on that website, only then it will throw an error. Then we can ask dev team, okay, this is throwing an error, is this expected or not? So if it is not expected, it is a defect. So that is how we do a pesticide paradox. And sixth principle is testing is context dependent. So what is testing is context dependent. So testing will depend on what product you are working. What we are testing, it depends upon the context. So context is like something, if you are working on a banking application, so you only test banking website, right? You will not go and test the e-commerce website. And if you are doing an e-commerce website, you do only e-commerce site. You will not do any other site. So that is what testing is context dependent. Whatever you are doing, you are doing only that particular testing, only particular content. So that is where the domain knowledge plays a major role. So if you are doing a banking, you should have a minimum banking knowledge, saying that you have a banking username and password, you log in, you should see the account, and you should see the account balance, and you should see the related accounts if you have any accounts related to the particular this thing. And all this happens only if you do a context dependent testing. And the seventh principle is absence of error fallacy. So absence of error fallacies, there is no bug-free product. There will be some other issue. It could be with volume of users or something. So absence of error fallacy, I'll explain you. So this page you have given, and it is working fine, and it went live into the it went live and people started using it. What happens is, suppose in a day you have tested only for 50 users or 60 users. This is called performance testing. Okay, if you have tested only 50 users and you have triggered this website for 50 and 60 users and it is working fine. So when on live, what happens is there are 150 or 200 users using the same UI page at the same time and the same pace. So what happens is it has a very high load on this particular testing. High load in the sense everyone started accessing the same page. Suppose you take IRCTC, right? So IRCTC, when you try to log in from morning 9 o'clock to 10 o'clock, it is very hard for you to log into the website only, because that is a time where you get the Tatkal tickets open, and you have to, if you have to try it, it is very tedious task for you to book a ticket, book a Tatkal ticket, right? So if you have ever tried booking an IRCTC at that time, if not, you can go tomorrow, you can check, or today after class also you can check. It is very hard, really very hard for you to log into the site at 9 o'clock. You should be logged in before 9 o'clock, 8:45 something, and then you can start. At least if you are logged in, then you can at least see the train tickets. So that is what. If there is a large load and you did not test it properly and you given it to the live, then that time it might there might be an absence of error fallacy. So fallacy is which is not true. Fallacy is which is not true. So there will be some, so you do not check that, you only checked for 50 users, but they are using 150 users, there might be some issue. Or if you have checked only for username at the rate 123 and login, and some other combinations you did not check for dollar or hash trick or something like that. So there it is not accepting username. So there might be some things that you have missed it, and that might come up on the live, and there is there you find a bug and they come back in the maintenance stage. So you have to understand first that there is no bug-free product. There is no bug-free product. So this is how we explain all 7 testing principles. So these are the basic principles that every tester has in mind so that he can complete the testing. See, first, what is the first principle it is saying? It is saying it will never prove. It will never prove that there is no defect. It is always has a scope of improvement. So if suppose in IRCT website, what I have to, if for 150 or 2000 members, if we are logging in at a time, it is so there is an improvement in that particular IRCTC website which they are working on the back, and these comes in like different requirement stages. Okay. So other requirements come up. So first requirement came up, we have completed, but there is some improvement. They come back again with say, okay, this is requirement 2. Now we have developed for 150 users. Now you want us to increase the load to 2000 users. So in the requirement 2, we do that. We'll check for 2000 users and all. So that is how those load testing and all we do in the performance testing. We don't do it in the manual testing. So don't worry, we not do such kind of testing, but basically we'll do like we create 3 to 4 username and passwords and we'll try to check whether we are able to log in or not. So those load testing and all we do it in the performance testing. And the second principle says that you can never ever test a product completely. So there might be some constraints or something it might come up. So total product, so whatever requirement we got it, we can do it, but we cannot like, so IRCT has come up with a requirement too saying that now you have complete for 2000 users, we do that requirement and we complete. But when we are doing it, there might be some scenarios where you are exposed only to that particular area. You'll not given access to that previous page and the next page. You should only concentrate on one page. So that is where you can say you can never test the product completely, like a total end-to-end product you cannot do it. Sometimes you can only work on the 2000 users load testing, and you can give you will give back to the client saying that okay, this is requirement is done, and you cannot go and test that whether it is going inside and these all 2000 users are able to going in the banking site and they are able to book the ticket. All these things you will not do. What is the requirement? Requirement is you have to website has to be ready for 2000 users and you made it ready and you give it. So that is third principle is static testing or early testing is same. Early testing, it is always good to implement early testing because to prevent the defect and to reduce the defect this thing. And defect clustering is a place where you find more defects in single page, where you have hundreds of defects and you tell the dev team, okay, this is where we saw more defects. So highest number of defects is called defect clustering. And pesticide paradox, it is not at all good if you do the same testing with the same positive scenario again and again. You should be in a position you can implement different scenarios, and you should be able to having a negative eye when you are doing a testing, because you should aim only for that error from that whatever you are testing. It's not the happy path you are testing. You should be good for testing both happy path and not happy path. And testing is context dependent. You only get the work on the product according to what you are testing. It's like banking, e-commerce, you only work on it. And absence of error fallacy is nothing but not true, and absence is there is no bug free product. This is what you have to keep it in your mind, like a principle. That's it. You have to keep it that there is no bug free product. But as a tester, you have to have this in mind that you should be ready to do any kind of testing. Okay. So now here in the third principle, what I told is QA and static testing and early testing are same. Okay. So now we'll learn about two types of testing. So what are the two types of testing? First one is a static testing. So static testing is nothing but testing if requirements are met or not. So this is generally called a QA thing that we do. And dynamic testing is nothing but if a product is built correctly or not. This is called QC. So you might be confused. What is this? What is this? Okay, we'll go into this. Static testing is built when product is not ready. We just make sure whether the product is as per requirement. And dynamic testing is we just execute the code and check if the code is working properly or not. So what is static testing? So when you start, when the product is not ready, suppose in this previous requirement, you were given a requirement saying that you have to build an e-commerce page which has to have a login page. Okay. So now what is the product is not ready. You just have it a requirement, and now what you do is you just make sure whether the product is as per requirement. So when the final product is coming to your state, your hand, what you do is, okay, this is as per requirement. Okay, username is there, password is there, and login is there. So that's it, done. You're done, your part is done, static testing is done. So static testing is built when product is not ready. So it is not ready, but you just make sure the product is as per requirement. So developer team will give you this UI face to you saying that, okay, this is how we are planning to check. So what you do is then you pull out the requirement document and see, okay, there should be a username place, and there should be a password, and there should be login. Okay. Okay. Now it is as per the requirement. So that is called static testing. And what is dynamic testing? Dynamic testing is we just execute the code and check the code is working or working or proper. Dynamic testing is generally coming into the unit testing. So unit testing is something like where the developers do. So when the developer team will complete the testing, right? So they do one round of testing from their side on the code perspective. So they check everything if it is working fine or not, and then they give us. So that is called dynamic testing. We do static testing sometimes in our product. We do static testing. We do different types of testing, and all those testings will cover in the next slides. Okay. 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 Till now, do we have any doubts? Or if I'm going slow, if I'm going fast, please let me know. If you have anything. Hello. Uh, Chefs, yes, I will try to. I'll try to give it, but not immediately today. Maybe like tomorrow or on Monday class. Sorry, tomorrow we don't have a class. On Monday, I'll surely try to give it to you. Okay. Okay. Do we have anything else from anyone here? Okay, I take it as a no, and then what else we can do today? 1 second. Let me check.
Hello.
Okay. So here. Okay, here I have to mention one thing. According to ISTQB, there is one point that you have to understand here in this chapter. It is called debugging. So what is debugging? Do you have any idea what is debugging is? Anyone in the team?
When you get errors, working on the errors
Yeah, correct. What you do with the errors?
to clear and make it execute.
Okay, do you clear the bugs?
No, no.
Yeah, yeah. So debugging is
It
nothing but, yeah, please go ahead.
debugging is finding errors.
Okay. No. Debugging is a kind of, no. Okay, I'll tell you. So debugging is nothing but process of finding and analyzing and removing the causing of failures in the software. Okay. So what is the thing is, you find a defect in particular website, and then what you do is you report it to the developer. Okay, developer, what he does is he goes into his code and he starts debugging the code. Okay, what he will do is he will go line by line, line by line, and he'll try to find out where exactly the code is failing, and he'll try to fix that particular line where the code is failing, and then there after debugging, he'll find the line and then he'll fix it, and then he'll come back to this. Okay, so that is called debugging. Debugging is generally done by developers. We'll not do anything. We only find out the defect from our end, and then we'll give it to the dev team. So dev team is the one who does debugging for this particular process of finding, analyzing, and removing the causes of failures in the software. So they try to analyze what is the defect, they try to remove the defect, and they also try to remove what is causing this error. Okay, so suppose a variable is hitting this thing and it is not being accepted. So they'll find, okay, why this is not accepted. Is it not a numeric that is being accepted, or this is not alphanumeric or something like that. So they'll try to find out the cause of the defect and they'll try to remove it. So this is one of the most important topic for IS2QB. So debugging, this you have to get into the mind saying that debugging is not done by a testing team. It only it's only dependent on developer team, and they try to analyze and remove the causes of failures in the software. So now that I have some time, I'll explain you ISTQB. Okay, there are few things in going classes. What I'll do is I'll tell you the concepts like K1, K2, K3, and K4. Okay, I'll tell you what K1, K2, K3, and K4. Okay, let me open the word here. Okay. So basically, when I tell this is a K1 concept, what you have to do is you have to remember and recognize and recall it, because this is for sure. You have to remember as is, like if it is a definition, you have to remember as it a definition. You have to, if you have to recognize it, you have to try to recognize, and you have to recall it. And what is K2 is, you have to understand the topic, and you have there might be a scenarios in ISTQB. What they do is that they give a scenario, and they try then out of it you have to try to explain how that scenario comes, and how on what basis it is coming, and you have to try to explain, and you have to, there might be some questions where you have to give reasons, and there might be some scenarios where you have to compare the situations, and you have to summarize few things. So these are all things where you have to do it. When I say it is a K2 topic for ISTQB, then you have to understand it thoroughly, and you should be able to explain it. And you have, if at all you have a reasoning question, there might be some reasoning questions based on K2. There might be comparison questions based on Q2, and also on summarization, you will get some topics from K2. If I say it is a K2 topic, you have to get ready for this. K3 is something like you have to apply the concept and get out of it. So if I say it is a K3 topic, so you have to apply that particular formula, or you have to apply that particular scenario, and you have to understand the question, and you can complete that question in ISTQB. And K4 is like analyze. You have to analyze that particular question. So suppose they have given you a scenario, you have to analyze, okay, on, so I told you in today's in today's section we have understood what is fundamental testing process. Okay, so what I told, when you are executing the test cases, it is an execution phase. What you are doing, you are analyzing the question. So so they ask, so the one of the question in ISTQB will be like, you start doing executing the cases. It's just an example, it will not be like the same thing. We'll also discuss the ISTQB questions in future in the Monday class, based on the chapter 1. But I'm just telling you for an example. So they give you like, you have given like, and there are 10 test cases and you have completed all the 10 test cases. It will not be a direct question. Test cases, something, all the story he'll hook up, and you have, then he will give you in the option saying that you are in a test planning phase, you are in analysis phase, or you are in execution phase. Then you have to analyze the concept. What concept? Test execution phase, where you will execute the test cases. So that is where you have to analyze it. So for K4 topic is you have to analyze it. So these are all the shortcuts that I'll be giving you from Monday. So that if I say it is a K1 topic, you have to remember that as is, like a definition, everything. And K2 is like you have to understand it. K3 is if it is an something like a formula or something like that, it is you have to apply it. And K4 you have to analyze it. Okay. So that is how we are going on ISTQB. So for today, defect clustering is like K2. You have to K2 topic, then you have to understand it, and you have to get that into your mind, saying that what is debugging. And also 7 testing principles. 7 testing principles is also like it's a K2 topic. You have to understand, you should be in a position you can explain it, and if at all they give a reasons, you should be able to find out, okay, this is from this chapter, and okay, this is you should be able to compare it, and summarization is also done. So this is how we are going in an ISTQB perspective. Just give me a moment. I'll try to figure out few of the questions till now. 1 second. I'll stop sharing. Okay. 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 Okay, I'll present you one question about this thing. Just try if you can do it. Okay, the question is, which of the following statements is correct? An error is caused by a failure in software. A defect is a result of an error. An error causes a failure in software that leads to bugs. Or the failure is another word of defect or bug. This is one of the ISTQB question. So can anyone try about this? Which of the following statement is correct? An error is caused by a failure in a software. It would be good if you unmute it, because I am sharing the screen. I cannot toggle between these two. It's okay. Even if you fail, it is okay. We just we can again go back to this particular topic and we can understand it. Okay.
Is it an error causes a failure in software that leads to bug?
Okay. And then can I get any more answers, please? It would be easy if you can talk. See, no one here is gonna judge you, or no one is gonna do anything. You just have to speak out. Only then we can
I
get
believe
it
it's the
more.
second one. Defect is a
Second one is
result
okay.
of error.
Defect is result of error.
Okay, okay. I'll give one more chance. If anyone is wishing to talk, we'll see the answer. No one else? Okay. The answer is a defect is result of an error. So this is not a direct question. See, the defect is result of an error. How is it coming? I have shown you. So the defect is result of an error. Because of an error, a defect is causing. And because of an failure, a defect is raised. Okay. So this is where how these questions are. The questions will be in-depth questions. You should like get the roots of this concept. Only then you can give the ISTQB questions. See, it is a very simple question, right? It is a very simple question, but there is a little tricky part here. So an error is caused by failure in the software. So it might not be a software, it might be because of anything. An error is caused, but what Error is caused defect and defect is caused failure. Okay. And what is the second option? Defect is result of error. Error causes a failure in the software that leads to bugs. No. What does error cause? What does error cause? It causes a defect. And error causes a failure. Okay, this is where it is going wrong. Error causes a failure in the software that is not correct. Failure is another word of defect or bug. No, failure is something different from defect or bug. It is not similar like a defect or bug. So this is how the ISTBQ questions are. So you have to get the concept very well, only then you can answer the question is proper. Okay. So that is why I told this is mandatory. Only if you get this diagram into your mind, it will be easy for you to answer that question. Okay. We'll see one more question. Okay, differentiate between QA and QC. Can anyone answer this? You just can try. It's not like we are doing any judgment over here. I just wanted to
Yeah,
listen few
QA is some
answers.
Quality analysis and quality control.
control.
Okay, good. Any one more point, please?
And QA is a product that is not ready. We'll just check the product as per the requirements. And
Okay,
QC is something we need to execute the code and need to check the code is working or not.
correct. Perfect answer. So that is what QA can also be called as static testing. QC can also be called as a
Also,
dynamic test.
dynamic,
Yeah.
yeah.
So that is how. So this is also one more question in from ISTQB. Okay. So this is how the questions will be. And on Monday, I have one more topic. I have two more topics to complete the chapter one. What is the psychology of testing and how a mindset of a tester and how a mindset of developer. So there are 2 to 3 topics. Monday I'll try to complete it and we'll have a quiz on Monday. Similar questions like IST will be questions. I'll try to figure out for chapter 1 and then we can discuss on chapter 1 so that you will get little confidence on chapter 1 and then we can move to chapter 2. So that is how we are doing it. 1 second. 1 second, I'll stop sharing. Okay, starting the share. Okay. So now you would have understood how the testing questions will be. So in the first chapter, we have completed what is software, what is quantity, what is software testing, what is defect, bug, and error. We have also seen one question today on this. And what are 7 testing principles? We have learned with examples and what is static testing and dynamic testing and guidelines of testers and psychology of mindset of testers. Everything I'll try to include on Monday's topic, and we can close the first chapter that is called overview of testing, and then we go in depth on testing, introduction of testing, SDLC life cycle. This is already covered. This is what is SDLC life cycle is. We'll again go through that SDLC life cycle and different SDLC models. We'll try to get some information on Monday, and every day I'll have few questions like this so that if we can talk out so that you will also understand how exactly you are getting into the point and how we gonna discuss on this. So this is all for today. You can happily reach out to me on my mobile number whenever needed. If you have any doubts, if you have some time, go through all these topics. It would be good. And Monday we'll have a little like 4 to 5 questions on all the topics that we have covered, so that you will gain some confidence, and then we can move to the next chapter. And to this, I'll stop sharing, and then if you have any questions, you can go ahead, or else we can wind up the call. Okay, sure. I guess you are in the group, right? I'm in a group. You can get it from there. Okay, I see there is no question from anyone. Have a happy weekend. See you on Monday. Monday will be, we'll try to wind up first chapter. Thank you all. Have a nice day. Have a great
Okay.
weekend.
Thank you. Thank you. Bye-bye.
Thank you.